Alrighty then, corn children. It is another fine day for learning. And today we are going to be talking about arithmetic sequences. Arithmetic sequences, awesome. Now, before we get into what makes a sequence an arithmetic sequence, let's just be clear, what is a sequence? Campers, don't overthink this. This is just a pattern of numbers. Okay? It's not a big deal. It's a string of numbers that have a pattern. All right. Now, that's just for sequences. We're going to talk about the arithmetic part in a minute. Let's just look at some examples of sequences, though, just so we have an idea here. Oh, look at that. She hasn't prepared. All right, here's an example. All right. 3, 6, 12, 24, 48. Ooh, yes, you're very smart. You've seen the pattern. To get from 3 to 6, we multiplied by 2. To get from 6 to 12, we multiplied by 2. And so on, and so on. Yes, you're very smart. Congratulations. All right, what about another one? All right, let's look at this pattern. Perhaps that is not so obvious, you smarty pants. Well, there's actually a couple different patterns. One pattern is to see that this is 1 squared, this is 2 squared, this is 3 squared, so perfect squares, the perfect squares of the integers. But that's not the only pattern. No. If we go from 1 to 4, you could say you're adding 3. From 4 to 9, you're adding 5. 9 to 16, you're adding 7, and then adding 9. Oh, so this pattern is the perfect squares, but it is also adding the next consecutive odd number. Yeah, let that sink in. Now, these are exciting examples of sequences. However, these are not arithmetic sequences. Let's be clear. These two here are not arithmetic. And that is the way you say that when it's an adjective. It's not arithmetic, it's arithmetic. All right, focus. What is arithmetic? Let's take a look at one more example. It'll be fun. Come on, all the cool kids are doing it. This last one is an arithmetic sequence. Let me explain to you why. Yes, you see it, don't you? Yeah. To get from -6 to -2, you add 4. To get from -2 to 2, you add 4. To get from 2 to 6, you add 4. 6 to 10, add 4. You become an arithmetic sequence if to get from one number to the next, and we call these terms, to get from one term to the next, you always add the same number. Not adding different numbers, not multiplying, adding the same number. Now, if you're like me, and I know I am, you're actually taking notes on these videos, so you may want to pause the video and get a chance to write down the following definition. All right, so there's my example of the arithmetic sequence, and here is the definition. An arithmetic sequence, and we're going to talk about this notation. This is a weird notation. An arithmetic sequence is a sequence in which each term can be obtained by adding d. D is the number that we're going to be adding each and every time to get from one term to the next. So in our last example, d is +4. All right, so adding the common difference d to the preceding term. All right, so adding the same number, which we're calling d, every time. Yeah, that's kind of fun, isn't it? Hey, let's talk about notation. Let's talk about some of how we talk about this, how we write this kind of thing. So that's my definition. Set that aside. Let's go back to this example that we have right here of our arithmetic sequence. Let's focus in on this one. All right. First of all, Actually, I'm going to use a new note. I'm going to use a new one. It'll be fun. We'll use a new one. Let's talk notation. Consider with me this sequence. Now, I'm going to name our sequence A, because maybe we'll have two sequences. So we'll have an A sequence and a B sequence. So you can call the sequence, the whole thing, by a name. I'm going to call this the A sequence. And here's our sequence. -4, 1, 6, 11, yada, yada, yada. Awesome, awesome. And if you look very carefully, are you looking? Yeah. To get from one term to the next, what have we done? Well, that's right. We've added 5. -4 plus 5 equals 1. 1 plus 5 equals 6. 6 plus 5 equals 11. And so on and so on and so on. So this is arithmetic, let's be clear. Because it is arithmetic, we have a common difference. It's called the common difference because if you subtract two terms, the second one subtracting the first one, out pops the common difference. We're adding 5 each time. 11 minus 6 is indeed 5. So, just so we're clear, this is the D value. The D value is not necessarily in the sequence, it's what's up here. It could be in the sequence, but it might not be. All right. The first term. The first term is just the first number in the sequence. Our answer of what is the first term is -4. Well, great. Here's your notation. Because I've named this the A sequence, if I write A with a subscript of 1, now I'm asking what is the first number in the sequence, and that's -4. Easy peasy lemon squeezy. So don't hurt yourself. If we want the second number, also known as the second term, your notation would be A subscript of 2. We shorten that verbally, A sub 2. And that would be the second number in the sequence. Oh, that is so wise. What if we wanted to talk, and we will, about a generic nth term? The nth term meaning any term really in the sequence, a generic what about way over somewhere else. Subscript A sub n, and we're going to look at how to come up with a formula for this. Now, the minute I get this little n down here, A sub n, the nth term in the sequence, we can also talk about the variable n. And n is just the number of the term. Now, immediately, there will be some confusion on some people's parts. So let's go and let's look at a very specific example. Do you see this 6 right here? Of course you do. You have eyes. Do you see the 6 right here? There are two numbers, two variables associated with this 6. I can first of all say that it is the 1, 2, 3. It is the third number. N is 3 because it is the third number. N is 3. But A sub 3 is 6. The 6 is the name of the number that came in third place. Like if this was a race, like a really bad horse race, the name of the horse that came in third is 6. Its ranking is third place. All right, so A sub n and n are different. I know that's going to be a little bit tricky. All right, well, if that wasn't fun enough, and wow, it was pretty fun, let's talk about all arithmetic sequences at the same time. What? Yeah, we can do that. It's not that bad. All right, so put that there. All arithmetic sequences. So we want to talk about this in general. All right, so here's what we're going to do. I'm going to put little spaces here for our terms. Yada, yada, yada. Now, in general, the first term we will simply call A sub 1. That's pretty generic, isn't it? It's the first term. Now, because this is arithmetic, though, To get from term 1 to term 2, we would need to add the common difference. So I have A1, and then I add D. And this term would be A1 plus D. Yeah, I know, right? Right? How do we get the next term? Well, to find this term, I would take the term before it, and I would add another D. So to get from here to there, I would add another D. Well, if you have one D, and you add a second D, you get two Ds. So this would be A sub 1 plus 2 Ds. I know, right? It's a pattern. To get from here to the next term, you would add another D. You'd have two Ds, you would add one more. I hope you brought your special goggles because it's 3D. Whew, yeah. All right, so, and we could continue doing this, yada, yada, yada. But let's look at this. This is the first term. This represents the second term. This represents the third term. And this represents the fourth term. Can we figure out a representation for the generic nth term? Well, there's a pattern. What? Every single one of these has an A sub 1. In the first term, there were 0 Ds. I can actually add that. No Ds. For the second term, there's an understood 1 D. Third term, 2 Ds. Fourth term, 3 Ds. It's almost as though the number of the term, take away 1, becomes the number of Ds that we have to add in. And that's the exact pattern. If this is n here, we need n minus 1 less than that, Ds. And ladies and gentlemen, this actually becomes a formula. This is called the explicit formula for the nth term, specifically in an arithmetic sequence. So the nth term can be found A sub 1 n minus 1 times D. I know, that is really exciting. We'll go from there later. Don't worry, there's more.